everyone, welcome to class. Hopefully you're having a good week here. Today is our last day for the week, so we're looking at week 12, day 2. Before we get into this though, I just actually want to give us some pre-reminders. I know this week has kind of been a little bit chaotic and it changed a lot with Tuesday's class. So make sure that you are completing 4.12 test before you watch this video. I just don't want to throw new content at you when you still are being tested on old content. So if you haven't done it, hit pause, go take it, submit it, and then come back in. Some questions have come up, and I just wanted to reiterate, I know I talked about this on Tuesday again. I just want to say it one more time. Yes, I took out 4.09 and 4.10 as required assignments. Now, they do show up on your, some of you, they do show up on your test. If you do, if they do, and you don't get them correct, just let me know and I'll adjust your grade accordingly. So again, you kind of just have to send me a message. I appeared as if it had taken out of the test, but for some reason, some of you are, it's showing up for. So obviously, I'm not going to punish you for something we did not cover in class. So just let me know and I'll take care of it on my end. Lastly, there were some questions that came up about the vertex being below the axis or above the axis. So I just want to clarify that if your discriminant is positive, it's going to be below the axis. And if your discriminant is negative, it's going to be above, which sounds exactly opposite. It's backwards, and that's why I just wanted to reiterate. It's kind of counterintuitive to what you were thinking and what may be logical. So I just want to throw that out there too. Okay, so again, otherwise we're just going to get started with 5.01, which is your homework for tomorrow. So ultimately 5.01, we are looking at a new unit here. And so before we get into that, we need to review factoring and least common denominator. Those are kind of the things that are going to help us out in this unit. So we want to make sure that we get that covered. Now, we spent a whole lot of time factoring. That was almost 2 full units of our so far of the content that we've done this semester. So if you are not comfortable with factoring, I'm probably going to breeze through it pretty quickly today. So send me a K-mail and I'll get you set up with some videos that you can watch to get yourself back on track if that feels like that's something that you would need to do. Okay, but first we're going to look at least common denominator. So all a least common denominator is the smallest, that's why it's called the least, number that is used in our denominator, so the bottom half of our fraction, that is in common to all 2, 3, 4, however many fractions you have. So if we're looking at our left example, I have 1/2 plus 1/3 plus 1/5. Now I want to find a number, the least common number, that 2, 3, 5 all have in common. So you can do things like list your multiples, 2, 4, 6, 8, 10, 12, 14, 16, and so forth. 3, 6, 9, 12, 15. Now so far we have 12. Our 6 is our least common denominator. But when we throw that 5 in there, it really throws it off. So listing numbers is one option to do it. You can also look and you can multiply. Well, 2 times 3 is 6, 6 times 5 is 30, and that's going to be the smallest number we have. So you can see then that that least common denominator ends up being 30. Now remember when we're finding our least common denominator, that you have to multiply. Oops. So if we're looking to get to 30, 5 times 6 gives me 30. So 1 times 6 gives me 6. 3 times 10 gives me 30. So 1 times 10 gives me 10. 2 times 15 gives me 30. So 1 times 15 gives me 15. So we have to stay consistent about, if we multiplied our top number, then we also had to multiply our bottom number there. Here we have 3/8 and 5/12. Well, I can do 8, 16, 24, and sometimes the bigger numbers we get to, it's easier to find a number in common, especially a smaller number, because we're not listing as many. So then again, you can see that that least common denominator was 24. So 8 times 3 gives me 24, so 9, or 3 times 3 gives me 9. 12 times 2 gives me 24, so 5 times 2 gives me 10. You can see the very bottom explains the whole thing. The least common multiple in 3 and 4 is 12. Well, when you list out those multiples, you can see that the smallest number that they both share is 12. So we're looking for multiples, which is different than a factor. Multiples are the numbers that we're getting when we get bigger. Factors are the numbers that make up a number. So if we look, we have 4/5 and 3/8. So ultimately at this point, we really don't care about that 4 and a 3. We're looking for the 5 and the 8. That's what's important to us. Sorry. When I'm in PowerPoint, I always forget to delete this when I'm making a video here. There we go. Sorry, I didn't want it to be distracting for you. All right, so what we do then, we can list those 5 and 8. Now, 5, 10, 15, 20. 5s are kind of easy. So what I like to do is actually start with a number that's not the 5 or the 10. The reason why is because I know that a 5 has to be either end in a 5 or it has to end in a 0. So if I can get to there from the other number first, sometimes it's easier. So 8, 16, 24, 32, and 40. Well, 40 is the first number I get to that ends with a 0 or 5. So that tells me my least common denominator is going to be 40. So 5 times 8 gave me 40, so 4 times 8 gives me 32. 8 times 5 gave me 40, so 3 times 5 is going to give me 15/40ths. So now I've created those equivalent fractions using that least common denominator. Okay, so let's look at factoring. Now there's ultimately 3 steps that we need to do when we're factoring. First, we always need to look at our greatest common factor, which is the opposite of our least common denominator. Now we're looking for the biggest number or variable that all of the numbers and the variables have in common. So if I'm looking for the greatest common factor of 12 and 16, my factors of 12 are 1 times 12, 2 times 6, and 3 times 4. 16 would be 1 times 16, 2 times 8, 4 times 4. So you can see then that the 4 would be my greatest common factor. That's the biggest number that they both share. That would be a greatest common factor, opposite of that least common denominator. Now we're looking for the biggest number that's made up. Then we can go into step 2. It says factor the last numbers of non-variable. So we are looking for this last number that's non-variable, the factors of it. So what multiplies to 3? Well, the only thing that multiplies to 3 is 1 times 3. Then we need to go back and we need to say, okay, that same set of factors, they need to add to the middle number. Well, 1 plus 3 also gives me 4, so that would tell me my factors then would be x plus 1 and x plus 3. Because 1 plus 3 gave me a 4, 1 times 3 gave me 3. So let's look at some examples about putting our greatest common factor together and factoring. So on my top left example, I start with 9x squared minus 3x. So we're looking for what the 9 and the 3 have in common. And in this case, they have a 3. So I can pull out a 3. They also have an x squared and an x. Well, that would tell me that if one has 2 x's and one has 1x, that the most they're going to have in common is 1x. So that would tell me then my greatest common factor is 3x. Because I'm dividing out what they have in common. Then what they have in green here, that's anything that's left over. So if we look at this, I have 9x squared minus 3x, and I'm dividing out a 3x from both terms. Well, 9 divided by 3, I get 3. X squared divided by x, I get x. 3x divided by 3x, anything over itself is just 1. So you can see then that my denominator here is my greatest common factor, and then I have everything left over to be inside the parentheses. On this right example, I start out with 5x squared plus 10x. When I look at that, 5 and a 10, what they have in common is a 5. They also have, if they have an x squared and an x, they both have an x in common. So again, doing that same thing. Let's look at the long example I have in the middle here. So we need to figure out what 4, 8, and 12 have in common. I can divide out a 4 evenly by all 3 numbers. So that's what I want to do. So I'm going to take out a 4 first of all. Then I want to look and see what variables they have in common. This one has 3 x's and a y. This one has 2 x's and a y. And this one has an x and a y. Now, I can't have more in common than what I have more with. So this one has 3 x's, but they all don't have 3 x's. That means I can't take out 3 x's. This one only has 2 x's, but they don't all have 2 x's. This one only has 1. And we always need to look for our smallest amount of variables. So I'm going to do an x and a y because I can't take more x's away if I don't have them. I can't share my pie with 7 people if I only have 6 slices. It doesn't work unless I start chopping pie. Yes, I know, I realize that, but I'm just saying we can't share more of what we have. It just doesn't work. So now that I know that my 4xy is my greatest common factor, but I need to do something with that greatest common factor. So I'm going to divide it out of all of my terms. And I just do it separately so you can see how I'm getting my answer. So 4 divided by 4, I get 1. Y divided by y, these are canceling out. So then I have x to the third divided by x. Then I have 8 divided by 4, and I get 2. Y divided by y, I'm still left with nothing here. X squared divided by x, I'm just left with an x. Here, my x's and my y's are going to cancel out. 12 divided by 4 gives me 3. So my greatest common factor was 4xy, and then I have x squared plus 2x plus 3. The next thing that we should always do is check, can I factor this number? Well, 3 times 1 gives me 3, but 3 plus 1 gives me 4. I don't have a 4 right here, so that means this is my answer. I tried to factor it. All I could do was take out my greatest common factor. Sometimes that happens. That's okay. All right, let's look at another example here. So I have 3px squared plus 51px plus 216. Now the first thing I noticed right off the bat is they all have one p in common. I'm going to get rid of that p. I'm going to say, hey, that's part of my greatest common factor. I don't know what else is, but for sure I'm going to get rid of that. Because they all have 1 in common, so I can take 1 away. But I also need to see if they have a 3 in common. Typically start with your very first coefficient. It's called our leading coefficient. If I can divide a 3 out of these other numbers evenly, that's the best place to start, because usually when we want to factor, we want it where it's just the x squared. We already got rid of that p, so if I can get rid of that 3, we'll be sitting good. So then 51 divided by 3 is 17, and 216 divided by 3 is 72. So hey, this works perfect. So I'm also going to take that 3p out, or the 3, and then that tells me that the 3p is my greatest common factor. So if I took the 3p out, I'm left with x squared. If I took the 3 out of the 51, I'm left with 17x. And if we already took this p out, then I'm just left with 72. So now I need to see what multiplies to 72 and then adds to 17. So I'm thinking to myself, I have to have some big numbers here in order to get to 17. So 72, I can do 2 and 36. Well, that gets me 2 plus 36 gets me 38. That doesn't work. Okay, then I have 6 and 12. 6 times 12 gives me 72. 6 plus 12 gives me 18. Hey, we're getting closer. But it doesn't work, so I got to keep going. 9 times 8 gives me 72. And 9 plus 8 gives me 17. So I'm going to use 9 and 8. Because 9 times 8 gave me 72. 9 plus 8 gave me 17. My greatest common factor, we can't lose that. I've factored this completely. And so we're sitting good. And that's our goal, is to see, first take out your greatest common factor, if there was one. There isn't always, but chances are that there is. And then what multiplies and what adds. All right, so just your reminders here, we really just went over 5.1 checkpoint. That is your only assignment that you have to do besides your test if you haven't done that. Now, 5.02 is everything that we just did, except for it's a few more questions. It's a little bit more review. This is actually Monday's work, and we'll go through this again on Monday. But if some of you would like to take it right after we do this quiz, that's completely fine. Or, excuse me, right after you watch this video, that's completely fine. It's the wrap up, so it's just finishing up this. Your mystery numbers today will be 15 and 48. And I will have your zeros and your schedule up this weekend so you can get ready for the next week. Have a great week. Take care.